We are from Volkswagen, the car company, and we want to talk about VR and AR applications in our car development. So this is my colleague Premislav, and I'm Oliver. And we get lots of questions why we are on a game developer conference here at the Unite. And to get an idea where we are from, so we are from VW Group. It's actually like quite a big, big company with lots of brands like Audi, Porsche, MAN, and so on. And you might recognize all the other logos there. And we have over 40,000 engineers in our company all over the world. And you might guess it's a lot of collaboration needed and communication and so on. So that's why we are here, because we created actually a team of game developers inside our company. So we call this virtual engineering lab. So we are really focused on the engineering process of a car, so car development. And we founded this new team in January 2016. And we are now about 16 software developers, and our main tool is Unity. And that's why we are here, of course. And we are sitting inside the R&D department. It's located in Wolfsburg in Germany, where our headquarters is of the VW Group and VW. And yeah, we are doing in-house software development for custom needs of the actually car developers. And we combine the VR and AR with simulation software, and therefore create special requirements from the colleagues over there. You can imagine in car development there's lots of prototypes, lots of physical mock-ups, and we try to reduce this amount of things, but also try to revolutionize the process how a car is made these days, because the requirements on a car are much different. But VR is not new for Volkswagen. There's a long history of VR. So we have like 20 years of history in this projection-based augmented reality or virtual reality, and with military-grade headsets and so on. So it's more than 20 years of research in, because, as I said, it's so expensive and so hard to collaborate on working on a car project that it's worth it to investigate in this area. For example, in the top left, you see like a cave environment with tracked hands and tracked glasses, so you have a stereoscopic view for sitting inside a car and judging the data. And you also see like projects from augmented reality space where service guidance is done on an iPad. But yeah, these days VR is of course different. You see it everywhere here. It's like consumer VR now. And it also has like lots of new good things on it. So it's like high quality, high immersion, and there's also big players behind. It's not like small industry tools anymore. It's like consumer grade software. So it's also really interesting for us. But why did we found a new team inside it? Because the software is also very important. So game engines these days unlock for us the possibilities we can do with this new hardware systems, like the Oculus or the HTC Vive or even the HoloLens. So we started quite early in getting into this game engine direction, but not with VR in focus. We started more, we wanted to visualize cars in motion. And this was actually the first attempt, just putting CAD data into Unity. It looks not so good these days, 2013. But actually it worked. So we had like 10 million polygons for a car, which is still heavy for Unity, even these days. But we threw a lot of graphics power on it, like a workstation with big graphics cards and so on. And we actually got it running with Unity version 4 and 32 bits. So we investigated more in this. And a year later, we had like a nice visual. We had two cars driving in 4K resolution with 60 frames per second. So we said, okay, it's working somehow, so let's do this further. So we were able to control the cars interactively on this game engine space. But then I got the Oculus DK2 on my desk, and I said, oh, that's interesting. It's the new class of headsets. It will be targeting the consumer market. The price point will be much lower. In the past, the military or industry headsets were about multiple thousands or 10,000s of euros. And these headsets will target a much broader audience. So I was able to directly visualize this quality inside Unity, inside an Oculus DK2 these days. and show it with a high frame rate and very high immersion. And 2015 got even more excited because the HoloLens came out, and it's the first one that is stable see-through AR, and it's actually solid and usable. And that's still the case that it's mostly only unlockable with game engine Unity. So that's why we still stuck to this, and we challenge a lot of classical industry tools with a custom-made game engine-based approach. So the high immersion requires high frame rates. That's, to sum it up, what's the challenge for the classical industry tools is. So Unity comes from this real-time world, and that's why it's so interesting for us. And when you have these high immersion, these high frame rates, of course, all the people get new ideas what they can do, how they can develop the cars better, how they can change their process, and so on. So that's because these new possibilities require also like fully flexible tools. And with tools like Unity, we can create custom internal tools for like all the 40,000 engineers we have, and replace physical mockups with complete digital ones and change the complete process. So these days we have established different Unity pipelines, and we have different 3D data formats we need to handle. So in the first place, in engineering, of course, there's a lot of different data. So we have engineering data like CAD, we have different materials, we have airflow simulations, CFD simulations, and so on. You need to judge every of these data, and it's really a collaboration between experts, non-experts, and all the different people. So they judge the data and bring it together. Because you need to know a car is developed by thousands of people, as I already said, but they also create data differently. They change it shortly before review meetings, so it's not like this. We are doing a marketing configurator and have some weeks to prepare the data. It's just we have some hours to bring the data in and just show it as it is. That's really important. And these cars can have up to, like for example, 35 million polygons, and also terabytes of numerical data, for example, for simulations and so on. So we need to handle this inside Unity and unlock both advantages. On the other side, we have cars with full configurations for our marketing purposes, for example. But we also reuse this in car development when they create new cars which are facelifts or successors of the previous cars. So we have there the data is more like what the customer can see, the shape of the car, but no technical data inside. No, it's more to attract the user or the customer and to show him the car. And it's like about 15 million polygons per car. And the process is a bit different, so it's not the data collection, and so it's very centralized in this thing. And as I said, we created since 2013 conversion pipelines into Unity. So now we can combine all these different data to different software solutions for the needs of the others. And we can directly show it in, for example, the HTC Vive and experience it with a high frame rate, but also show it in Microsoft HoloLens with a remoting functionality. I will talk later to this about. And yeah, what you can do with the data, for example, in what you see here, will Premoslav now show to you. So.
Right, thanks, Oli. So yeah, first obvious thing to do with this kind of data is obviously to display it in VR, and we got this line of products called we call it virtual concept cars. It's basically a collaborative multi-user environment, virtual environment, which enables experiencing the nature of the vehicle and the early development stage in a realistic manner. So it enables quickly importing like the latest construction data into VR without any simplifications, and make design decisions easier and faster. So engineers explore the car at the full scale, at the full visual fidelity, and consult each other on the design choices in real time. And such an early assessment of the vehicle enables like drastically reduce the alternation costs. And of course, like Oli mentioned, it's like the main challenge here is like the huge amount of data we need to process in real time. Often the CAD CAD meshes exported from CAD software are like 35, even 50 million polygons. Every single mechanical part is there. And the data changes very often from day to day, and also is reviewed, is used for revision equally frequently. So yeah, please have a look in the short video clip. Yeah, so with Unity it was very easy to add like extra stuff like multiple lighting conditions, time of the day, or even different weather conditions to our visualization. But VKF is much more than high quality VR. As the mobility concept changed, the interaction between the car, between the passengers and the car systems are getting increasingly important, and therefore VR enables also us to evaluate the operating concepts at early stage as well. So it helps us assess natural interactions with the vehicle, detect some logic errors in the operation, and also what is very important for us, how much the system distracts the driver from the traffic during the journey. So for example, like user experience designers can decide what can be like on the touch screen, what needs to be like implemented as a physical button, and so on. And as you know, like first thing that everyone wants to do in VR is want to like touch stuff, and that's why we cooperate with Stanford University Shape Lab, which explores how we can interact with digital information in a more physical way. And they built for us something that is called shapeshifting. It's basically like a pin display with like actuated pins. They are currently around 5 by 5 millimeters. And the idea is that we can build we can have a physical dashboard matching our virtual dashboard, and quickly change vary between different types, different models. Another thing we're looking into it is we don't want to only like experience like the car standing still. We want to drive it in a traffic situation on the road. And we're using software called Virtual Test Drive by Vires, a German company, and they provide and VTD provides like a complex road networks with pavements, bicycle lines, and of course traffic simulation, pedestrian simulations, cyclists, and so on. So you can get like very complex simulation scenarios, like you can't build it with Easy Roads in Unity, at least not yet. But yeah, I mean, you can ask, yeah, it's been games for like, I don't know, 20 games, traffic simulation. But what we are really interested in is actually like a sensor simulation of the car. As you know, like modern cars are packed with different sensors, different type of radars, cameras, infrareds, ultrasonic sensors. So we'd like to have this emulated in software, so the engineers can build the advanced driver assistance systems, ADAS, and test it in virtual environment first before they will like send the car like to actual road. Also benefit is like reproducibility of the test scenarios, and you can have like a wide test suite for different road situations. Yeah. So as Oliver mentioned, we also bringing like a lot of simulation data, which is done on supercomputers. And one of the examples is like, you can think of this as a virtual wind tunnel. It's basically visualization in VR of pre-computed CFD aerodynamics data. So the engineer can like literally move inside this data. So it's like massive vector. Original data is, I don't know, hundreds of millions of like sample points vectors where the air is going. And so in contrast to existing systems like typical scientific visualization software like Nsight or ParaView, It's real time, it's in VR, and it's very interactive, it's very intuitive. So different scientific visualization methods, like streamlines, particle traces, count planes can be quickly combined just with the hand gestures or with the controllers. And with Unity, it was really simple to add, like, again, cool stuff to it. So we used the inbuilt particle system to get like something similar to what they see in the wind tunnel. And yeah, so I'll just move to video. So that's how the interaction looks like. And of course, we showed it to like aerodynamics experts. Well, they find it like really, really cool, really nice, but not like something that will change drastically the way they work. But after like further exploration, it turned out that it's actually like a great communication tool between experts, like aerodynamics experts and non-experts, because you can have like streamlines or for example, cut planes, which is like a main visualization tool for experts, but like non-experts, they don't understand what's going on there. But when you have like this particle stream, I mean, it's obvious to everyone, right? I mean, you got the air flowing from here, flowing to there, it's reaching this amount of air, reaching like this part of the car in this velocity. So yeah, maybe I can't move. Okay. Just one, yeah, the streamline. So there's another like a scientific visualization. So the coloring is basically the velocity of the air. Yeah. So the next idea was, okay, maybe we also had the data from like interior airflow of the car, so air conditioning and defrost or heating. And we found like pretty cool to like like just wave your hand and see what kind of air is coming through your fingers, and that's what we implemented. So again, like imagine like holding a cigarette. It's very intuitive. You can see where the air is coming, and this is something like that people really liked. Okay.
Yeah, another very important part is safety in a car, for example. So we also got all the crash simulation, the FEM simulation data into Unity. So then we are able to visualize it in a very sophisticated way. And as in the CFD data, you can just stick your head into the crash, and you can just look into the data, and you don't need to be an expert in the actually simulation software. You can just control it with your head and your fingers. Also the sophisticated shading helps to see all the surface deformations and so on. And you can analyze the data now in multiplayer, so you can see multiple persons looking at the data. They can even be in multiple places in the world, and they can work together in a completely different manner in VR. And since we are in Unity, we can do the shading as we want. For example, we just put a glass material on stuff which is not interesting for us and wanted to highlight the safety systems in this example. So it's just unlimited possibility. Once we have the data inside, we can just do whatever we want with it. So we can create like a special software for all the crash engineers. Here are also some examples of this software, and it's all rendered in real time in VR, so you can just experience it as it's in the video, can just go through it, make it smaller, make it bigger, and so on. So that was shown that we have lots of possibilities to experience it in a completely virtual world. So that you can see the data in a different way and be very immersed. But sometimes, of course, the process is not completely digital these days. There's lots, for example, in design studios, there's lots of clay modeling and so on, and physical prototypes are existing. And that's why augmented reality is also interesting for us. So there we can combine both worlds, the digital and the real world. So we can have access to both advantages. So, for example, we can have the right scale directly. We can have a one-to-one car beside a real car and see it directly, or we can put stuff onto clay models which is currently not finished in a prototype, like the headlights or different color schemes and different bumpers and so on. So for example, we used the aerodynamics data we already got and exported it for a HoloLens suitable format and put it onto a clay model. And then the clay model designer and the aerodynamics experts can find the compromises. You can visualize virtual cars side by side, you can show technical data, and you can do it completely in a new way, which was not possible before. And as I said, it's in the right context, it's in the right scale, so it's very different. And you can also augment different rims or different headlights onto these 1-to-4 models, for example. And you can also say, I want to experience it in life size, and then that's really the actual size of the car. That's can be a problem in VR, that the scale or the size perception is differently. Sometimes the people who are in VR say, it's too small, the steering wheel is too small, and then the next guy comes in and say, it's too big. I'm feeling so tiny, the steering wheel is so big. And so that's a bit of perception there. And in augmented reality, you don't have these problems that much. We also implemented that a bit of a hybrid approach, that the classical 2D designers can also bring their 2D Photoshop sketches, for example, into the 3D world. So you can draw directly in Photoshop, for example, and draw a rim, and you see it onto a clay model projected. So it's a mix of all these different creative tools. But to render stuff on the HoloLens, you can imagine it's a mobile device. You need to decimate the surfaces, the data, like a lot. As I said, we are like 30 million polygons. You cannot render it on the device. And in the design studios, it's really important, or even in CAD reviews, it's really important that you show the data as it is. So you can't say, I reduced the data, it looks still good, but it's not your car design, so just take it as it is. So we need to show the data in a big kind of view. And therefore, we want to have the advantages of the HoloLens, but still like big computing workstation power. And that's why we can show all our models in a life-size view and with holographic remoting inside Unity. So imagine she's a designer and she got the latest car design and wants to review it, and she can just look out the window and see it in life-size because it's like 7 meters away or so. The actual car also fits in the field of view of the HoloLens, and she has still the complete sophisticated shading of like our Unity models, all the lighting and the high quality CAD data, because we are using a workstation with a high graphic card and streaming through Wi-Fi to the HoloLens. And it's built into the Unity editor. You can directly use it, and you should give it a try. If you are a HoloLens developer and have high poly data, and just type in the IP address and you can stream directly to the HoloLens. So you saw we are reviewing a lot of this classical engineering data. We can show it to lots of people in multiple user with VR, with AR. But of course you ask, don't they want to create the data in this new medium? And that's currently, I can give you a sneak peek where we are currently working on, because of course we want also to create the data in this kind of thing. So we are currently working with our design colleagues to edit NURBS surfaces directly in Unity in VR. So we have Leap Motion input, a VR HTC Vive, for example, and can render the NURBS and model it. So you see the hand input is changing the lattice rig here to modify the NURBS surfaces. You can imagine that's the dashboard of a car, and you can just edit surfaces and find the right shape, find the right compromise with a colleague, with the other design colleagues, and you don't have to switch the medium from 2D to 3D. You just do it naturally, like somehow like clay modeling, but in the data. And we use Leap Motion input quite often because we feel it's very natural for all the people, because we have hundreds of people working on the software, and we think it's quite important that they are directly into it, and the size representation is also good if you see your hands, and you feel more immersed if you have your hands, and you don't have to say, okay, push this button to get this, use this button to get this. It's more like a natural user interface. And Kay, will you give you some outlook to other research projects we are currently doing?
Yes, just to mention that actually at the Virtual Engineering Lab we do like sort of research also in academic sense. So one of our colleagues is working on a machine learning algorithm for like artistic style transfer. And yeah, I think the image explains everything. So of course we want to use it in the automotive context to mix different styles and to get like inspiration for the designers. Yeah, another topic is also like real-time GPU ray tracing. The other guy is working at like PhD-wise. So yeah, I think that will be all. Thank you very much for your time.
No.
Yeah, and we are hiring. So yeah.
Yeah, we just wanted to let you know that we are also doing VR stuff and not only in the game industry, but so give us a call or write us. Okay, thanks. Any questions?
You've shown quite a lot of data within Unity. For comparison, I have a GeForce 1080 on my computer at home. There's no way that I'd be able to run half of that on my desktop, is there? Is it just a supercomputer that you need to be able to?
No, it's
display this sort of
classical game graphics cards. We use, of course, like the professional graphics cards from NVIDIA, but they are not faster directly than gaming graphics cards. So with a 1080 GTX, it should work. We also use this in our offices. So it's not a supercomputer. It's just a hyper. It has a lot of RAM, but not different. It's not like HPC. The simulation in front is done on an HPC, a supercomputer, but not the visualization. It's done on a classical gaming machine.
Okay. Yeah, so of course we're not using the data as is. So in case of Airflow, the original data is like 20 gigs, just the vector field, right? So we resample it on like uniform grid to make it real time. It's around 200 by 200 by 200 cells, averaged a bit. So it's 8 million cells. So it's doable on a GPU or on the CPU. Yeah, the problem is that Unity wasn't designed as a tool for scientific visualization. So I think currently the main limitation that it's, as far as I know, it's fixed already, so that you could have only 65,000 vertices. So like single part usually has to be split in like 20, 30, 50 meshes. And of course, like each mesh is, as far as I know, like a draw call. So for example, we had like early access to VRWorks implementation, like using dual graphics cards, but there was no like speed gain because they're using like 2 graphics cards. So maybe with like 32-bit index buffers that will change. We need to try it.
How many people are actually using the stuff that you're doing? I mean, you really generated a lot of different applications, let's say, and do you just go to them, show them what you did, and they're so how do you say? I'm so happy about that you just start using it right away, or is it just is it all more like you're trying to introduce them and you're trying a lot of stuff?
Yeah. It's a 50-50 split. So mainly every software we showed here is developed with a colleague from the actual department. So they are the product owner in this case, and they come to us with an idea. So sometimes we do it more from a technology kind of view and say, okay, we could do this. For example, with the Airflow, it was like from our idea to make it. But most of the time they are generating the use cases, and we have, for example, with these review meetings, there are hundreds of people reviewing the data, for example, in 1.5 weeks. But then, so it's not used on a daily base, more on milestone base. So they review data like 3 years before it comes to this on the street. Then they meet with all the people involved and check all the data together. So we have these kind of users. But of course, the designers are like daily users then from to model the software, the car, for example. So it's differently, depends.
Yeah, so it's, if I may add, so it's a good question, because of course, like in terms of VR, it's like you make a clean cut between, you radically change the way people work for like last 20, 30 years. So of course this is not easy, right? But like with HoloLens, you can make it more gradual to people to show it that it actually works, like add bits here and there, and to augment their work as well. So we get different ideas. There's no one way. For example, like initially with the Airflow, we're like had this idea that it's possible to do it and show it to experts to basically as a main target group. But then it turned out that for them it's not much gain. Of course, it's cool, but it won't change because they actually print stuff on the paper and analyze like the cut through the car. That's how they analyze the data. But later it turned out that it's like a great communication tool between experts and non-experts. And actually all the virtual concept car is like a communication platform at the moment. I think that's the best way to describe it.
And it's actually used for real milestones, so we already replaced complete milestones which used to done with physical cars, which cost about like 5 million euro, and replaced it completely with VR. And we have lots of different car projects in parallel, so it's worth it to do it in VR. So.
How important is haptic feedback? How much research do you put into that?
Yeah, I mean, to be honest, like we don't know because we don't have like the haptic device yet, so we can't compare. But of course, like everyone asked for it. Like everyone, we always laugh. Like everyone asked, "Have you thought about the gloves?" So.
And of course, we have like a long history in glove using in the last 20 years, but it's not doable for us if we have like a changing person like every minute. It's sweated after 10 minutes and so on, and they wear it for example, the head of engineering just recently had the HTC for 40 minutes, and if you just have then gloves, and it's not really force feedback you get, it's just haptical vibrating, so that's why we are more looking into this shape shifting, where you really got this pressure that you can't go further into the data. Of course, it's important that you feel it more. So we got asked a lot about this.
Yeah, like we don't know, but we think it's very important. Like if you interact with some screen, you want to touch things, you want to feel it, you want to get it. But yeah, we should get the actual thing like in the nearest weeks. So
and I'm
we
sure
we can tell a bit more how much impact it made to the.
But there's also in our research department, there's lots of studies around perception in VR, what's needed, what's not. So there's also psychologists looking on, because we want to be sure that what we decide is later looking good when we produce it. So it needs to be valid. That's why we have so much history in research and on doing these kind of things. Thanks.